I'm yet to decide exact number, and the remaining 60 to 70% will be covered by this Viva and the written exam like that. So mostly the again out of that suppose out of that 70 marks, maybe I can say that maybe 40% will be on Viva and 40 marks 40 will be on Viva and the remaining 30 will be on the written like that. So little more on the Viva again. Okay. So the exact distribution I'm yet to decide like that. I have not yet decided. So based on, but this is approximately like that. So it's basically I should say that almost equal division on this Viva written and the weekly Vivas. You should say like it's almost equal distribution like that.
So written exam will be individually or like it will be.
Uh-huh. Written written exam also definitely will be individually, right? Yeah. Sorry, not individually. It will be at a time, like just like you have your mid-sems exam. So we'll have that kind of. Yes. Of course, we don't have that VBox system. So we'll just try to use maybe only the Hangouts, right? You can just turn on your Hangouts, and TA will be monitoring, and we'll have our exams like that. Written
So
exam.
basically, we will scan and send in the mail the answer sheets.
Uh-huh.
We will scan the answer sheets and send in the mail.
Yes, yes. Some kind of uploading format.
Okay.
Just like we have this, you upload your group this one, right? So we'll have this uploading like that, uploading system like that.
Okay.
Okay. Yeah. Any questions? Oh, I think 1 week before the exam, I'll let you know the details like that. But at least you'll be prepared for the Viva on 18 and 25. Those who are giving on 18, this to be prepared. And so basically, it will be whatever you have done till till maybe. Of course, I won't be asking questions on what we'll be doing on 17 definitely. So till the 8 experiment, you can prepare again. Clear? Yeah. So today's experiment is based on whatever we have learned. So we know that we have analyzed so much the CD amplifier, common emitter amplifier. So in the common emitter amplifier, we know that there are different parameters. One is the beta AC, or if I try to draw the small signal and right small signal model, then we have this difference, right? Beta is there, RBE is there, or this is basically uh, it is sometimes written as RPI, or I think the teacher has used RE, right? RE, that kind of
Yeah.
notation. So different notations are used for this resistance. So and so now, whenever if you have seen, or if you will be seeing a transistor, basically BJT, right? It looks something like this. Now it's of this terminal, right? Base, emitter, collector, right? So each of this terminal, whenever it's connecting to inside, we have this PN junction. So this terminal, whenever there is a contact between because these are of metals, and whenever it comes in contact with the PN junction inside, there is a resistance, contact resistance, basically. So this is modeled by this RBB dash. So this RBB dash means the base terminal resistance, and the base emitter resistance. So which is, what is this formula? Can you tell me what is this equation? What is this? Someone would like to tell?
76 millivolt by IE.
IB, right? So this is BT by IB, right? So if you're so this is basically not the T model, this is pi model. So that's why this resistance happens to be BT by IB. Okay. So and this is of course this is a constant resistance. It's a constant resistance. RBB dash is a constant resistance, and of course we have this current gain, the IC, which is basically the I should say that delta IC by delta IB, right? And we also have this small signal transconductance, which is given by del IC by del BBE, right? So where this VBE is the this voltage, right? Following. So basically, we have to find out all these parameters. All these parameters like that. So now, of course, we'll be using the same this one. We'll be using the same BC547B, and we have different resistors. And this is the this is the basically this is the circuit configuration that we'll be using. We have VCC of 10 volt. So this is 1 kilo ohm resistance. Again, today I'll also be showing how do we do the simulation. I'll be showing it a practical demonstration in LTSpice. Of course, these resistors will be varying. So of course, in the lab, when we are doing physically in the lab, a port is used. A port is used of 1 ohm. Like the maximum resistance it can achieve in this port is from 0 to 1 ohm. But here, because we don't have to use a port, you can just vary the value of the resistor. So you can just plug in different values, and you can just do the simulation. These different values are given. So now you have to adjust this V in such that your VBE observed here is around from 20 millivolt to 100 millivolt. So that's the voltage that is observed, VBE basically, right? And the frequency that you are supposed to use for that this one is around 1 kilohertz. And then you need to note, you need to slowly increase this this resistance, so that your IB increases, and then you should observe this VBE voltage, because you know that this RPi or RPE will be changing. So based on that, you need to find out this voltage, and this will give you the information. So now, based on this, what are the observations that you are supposed to take is, since you are changing the also not an important point here in this notation, the whenever we are using this capital I and capital B, it means that it's a DC component, and whenever you are using small I and small b, we are considering the AC component. So you should be aware of this and make sure. So please don't be confused with the AC and DC component. I hope this point is clear already. Like you already know what is DC and AC, so I'm not going into that. So now, as you are changing this resistor, your this DC current will be changing. So you can just note down this DC current, and based on you already have given an input V, which you can keep it fixed, no problem. And you will be measuring the VBE, which will be changing because the resistance seen from the base to emitter will be changing. And then of course then you have to measure the input resistance Ri. So the input resistance is the input resistance is the resistance since at this point, right? Ri. So that's the resistance, and this is this is how we calculate the Ri. So basically this Ri is nothing but the summation of these RBB dash plus RE. So if I go back to my small signal model, then this combination, like the impedance looking here is RI. So how do I find this? How do I find out this? How do I find out this resistance Ri? So basically, to find out this this resistance, it's very simple, because if I am applying some voltage, all the AC signal current will be flowing in this direction. It will not be flowing up. So if I can find out this resistance, this current, right, flowing through it, I. Then, and if I know this voltage, we know this voltage is VVE, right? Because this is ground, E is ground, so this voltage is VVE. So then what will be the current flowing through this RS? Small current RS. Can someone tell?
V in minus VBE by RS.
Yes. So it is V in minus VVE by RS. Of course, all these are small. So correct, right? So then if I divide this VVE with this current IRS, then I will get my input impedance here. So this is how this formula is given. So Ri can be given as VVE, Bn minus VVE by RS. So because we are considering this AC signal, AC component, so you need to consider the peak-to-peak amplitude, right? Peak-to-peak, value, not the amplitude, peak-to-peak value of the sine wave, right? So that will give you the so you need to consider the peak-to-peak value of the VBE, peak-to-peak value of Vin, peak-to-peak value of VBE by RS, right? And then then you have of course we know that Ri is RBB dash plus RB dash E, and since we already know that this is VT by IB, right? So based on this information, we can calculate this RBB dash, right? So yeah, or the other way to do the calculation is, what I can do is I can just make a plot of, because I already have this IB information, and for different values of this one IB, I know different values of RI, right? So what I can do is I can do a simple plot, right? Basically, if I do because this is a linear relation between IB inverse and RI. So if I just do a nice plotting between this Ri and IB inverse, this line will be intersecting that this at the Ri, right? So basically the y-intercept will give you the RBBDS. It's very simple, because I'm just drawing a straight line. I have the information of IB, and I can calculate IB inverse, and I know the corresponding value of Ri. So if I just do this plot and find out, because I'll have different points, something like this here, and if I just plot it and try to I just need to extrapolate it, and then just make it meet this y-axis, and then this intercept will give me by RBB test. I hope this is clear. I think. Is it clear? Any questions on this? Okay, so if you don't have any question, let's move ahead. So this is fine. I think the manual is quite clearly explained. So so next to find out is, how do we find out the beta value, right? So beta value is nothing but again IC by IB. So we already have known how to do the calculations of IB. So IB is same as whatever I have shown before. It's nothing but B in minus BB by RS, right? And of course, because what happens is this impedance is much smaller. 47K is much smaller than this RL. So this is basically RC, and this is RL. Since RL is much smaller than RC. So the this IC will be prominent, like the current flowing through this will be prominent in, I'm telling in terms of AC signal. So then this will give you this one, this will give you the IC. So that's how you calculate the beta. So beta is nothing but IB by IC by IB. And how do you calculate the IB? Again, it is Vn minus Vb by Rs, and IC is nothing but the current flowing through the RL. And of course, you can because the beta has to beta is different for AC and beta is different for DC. So for calculating the beta DC, you can find out the IC and IB. So where IC is the current flowing through the current flowing through this one. This is the IC, big IC. DC is IC, and IB of course is the current flowing through this, which is IB. So if I just divide the two DC below, then I can get the beta for DC. This again also I'll be demonstrating, right? And of course for the transconductance is also simple. Whatever the IC that we have calculated here, just take the peak to peak value, and then the corresponding DBE that we have observed, you can take the peak to peak value and you can just divide it, right? So basically this also is mentioned here. That's how you calculate this game. So let me show you. This one, the LTSpice. And any questions till now? Any questions? So I already have constructed this circuit for yesterday's group. Any questions? Everyone hearing me?
Yes.
Okay. Is it clear? Any confusion?
No.
Okay. So this is already constructed, right? So I have my this one. So please use around 600 millivolt. 600 millivolt peak to peak. If you see the information here, I have an amplitude of 600 millivolt, frequency of 1 kilohertz, and of course this 47K and this one. So the port that I have used is I have used maybe 1K. So you can keep increasing maybe by 20K. Keep increasing it, and then your IB will change, right? So now. Of course, you have this decoupling caps, put this 1 ohm. So this is exactly the same one, whatever is shown here. I have written this, I have drawn the same circuit in the LTSpice. Nothing, no much difference. All the values are already given. So you just need to draw it. Okay. So draw it, and then you can just do the simulation, right? So to do the simulation, you see, you can just suppose you just plot this one, and then plot this one, right? So you can find out the peak to peak value, right? You know that this is the peak to peak value for the V in, and this is the peak to peak value of the VBE, right? VBE, and you can take the difference and divide it by this resistance, right? Then you will get the current basically. Or other ways, the simple way is, even you can, if you just plot this one, also will give you the current, right? So this also because this is easy in this is easy in LTSpice in simulations. You can even plot the current, right? So the if you just get the peak to peak current, right? Peak to peak current, right? And then also there will be just 1 minute. Sorry for interruption. Yeah. So mm, yeah. So you can plot this also. You can plot the peak to peak voltage, peak to peak this one also. So that also this is also the other way that you can do it. So if instead of instead of so you can get this current directly also, and then of course you can take the peak to peak value of the VVE, right? So you can take the peak to peak value of the VVE, right? Peak to peak value of the VVE. So you have this peak to peak value of the VVE and peak to peak value of the this one. So if you just divide it, then you can get this one like that. Yeah, you can get the resistance like that. Any questions on this? Any questions? People are hearing me, right? Hello, everyone hearing me? Yeah.
Yes.
Yes.
Okay. Okay. So the next is, of course, then once you know once you know this IB, once you know this VN, VBE, definitely you can get the resistance, and then based on that you can just plot this curve, and then draw the y-intercept like that. So this is the one, and the next one is of course to calculate the beta, right? So you just need to get the IB by IC. So what you can do is you can just plot this I, right? You can just plot this I, and this also is we already plotted, right? So of course this is this I is IR4. So because you know that this is very small, so it's better to plot it separately. Don't plot it together because you know that IB is very small compared to this R, because the beta is we know that it's more than 100 times. So because of which this is it cannot fit to plot everything on a same space. So if I just delete this one, and you can just note down this one because it will be in microampere and this will be in almost milliampere, right? So if you find out this current by this current, this also will give you the this also will give you this one, the beta, right? And for this IC by IB, of course, here also we are supposed to calculate the DC bias current, right? If you want to plot the DC bias current through this, of course, we can draw something like this. We can plot the DC. So, but it's IR2, right? So it will have some. So you can, by doing this, you can find out this DC component here, like that. So DC component, and to get the IC also you can plot out this IC like that. Of course, there will be some small signal there. If you want to, so the zero crossing point will be the IC. But if you want to get rid of the, if you just want to get a pure clear DC, then what you can do is you can just make this amplitude of this one as 0 volt, right? 0 volt, and then you can replot it again. So if you just replot it again, then whatever the value that you'll get will be the DC value, right? So from here you can exactly get the DC value of IB and IC, the DC one. So from there also you can calculate the beta DC. Any questions on this? Any questions? How do we calculate this IC and IB? So this is a DC value, so you need to turn off the voltage source, then you can get like that. Any questions on this? Any questions? And of course, if you want to measure the ZM, it's also for measuring the ZM also it's very easy. So what you need to do is again make it as 600 millivolt, right? 600 millivolt, and then you can plot this by this BV. So let me delete all this one. Delete. So delete. So to do that, you can just plot this IC by PBE. So if you are if you just take the peak to peak value and the divide, the ratio will give you the GM, right? So basically, you just need to calculate this current and the this voltage VBE. That also will give you the GM. So that's how you calculate all these parameters that we have mentioned here. So this quite simple, very simple experiment. You just need to know what all you need to measure and what all you need to see like that. Okay, any questions? Any questions till now?
Hello, sir.
Yes.
Sir, how will we change the value of the resistance of the pot?
Oh yeah, you just need to 1K. You just need to increase it, right? Nothing.
Up till how much?
You can just, so here we have mentioned you can go till 10 readings. I have mentioned here, so you can take 10 readings like that. So you can just increase by 20 each like that.
Okay.
So okay, yeah. So just I think all things are very clearly mentioned in the manual like that. So you just need to take 10 readings. So all these graphs and all those things, what you are supposed to do. If you already have it's in the website. You already have got the manual, right? So something which is not required, I already have crossed it. Don't need to do this like that. Okay. And what all things you are supposed to do it, it's also finally you're like this. Any questions again? Okay then. I think all the TAs are here, right? So if you don't have any questions, anyways, I'll be available till 5 o'clock. So if you have any questions, feel free to ping me. And
Correct.
hello, yes, yeah, yes, and of course. Uh, Other TAs are also here, right? Yeah, I think today the group who is taken care by this one, she informed me that she has a placement interview. This one, Purna Chandrika. So she will be taking Viva for this experiment, for the last experiment, next week, like that. I request TA to take Viva of 6A and 6B together, right? So 6A and 6B together. I think we are 6A and 6B is remaining. And then next week we'll have the last Viva for this experiment number 7. And I think this will be the end of the Viva session like that. And yeah. Okay then, Sitya, maybe you can download the attendance and send it to me. Yeah.
Yes, sir. I have downloaded, sir. I'm
Okay,
sending.
great. Yeah.
Okay, sir.
Okay, everyone. So again, if you want, you can leave this meeting. But as I mentioned, I'll be available till 5 o'clock. If you have any questions, you can just ping me in the MS Teams.